Welcome to online lecture series on first order partial differential equations. In this lecture we are going to solve some partial differential equations which are non-linear by reducing them to standard forms, standard form 1 or standard form 2 by taking suitable substitution. Okay, so directly we will go into the problem. We take this example problem. Solve the partial differential equation x square plus y square into p square plus q square is equal to 1. As you can see, this is a non-linear partial differential equation because we have p square and q square here. And this is not in any of the standard form. Of course, it involves p, q, x, y terms, but px terms cannot be separated from qy terms. So, it does not come under standard form 3 or variable separable form. So we need to take some substitution so that it may be reduced to any of the standard forms. So when we have equations of the form f of x power m into p, y power n into q, or with z term is equal to 0, then we are taking these substitutions. Capital X is equals to x power 1 minus m when m not equals to 1, and log x when m is equals to 1. Similarly for y also. And when we have equations of the form f of z power n comma p z power n comma q is equal to 0, or variable separable form of equations, in that case we are taking capital Z is equals to z power 1 plus n when n not equals to minus 1, and log z when n is equals to 1. But when we come to this equation is not in any of these forms. Here we cannot separate xy terms and pq terms. So we have to take a special substitution here to reduce it into standard forms. So we have here x square plus y square. So whenever we find x square plus y square, we can take the polar coordinates for it to reduce it to the simplest form. So we take the polar coordinates here. We take x is equals to r cos theta and y is equals to r sin theta, and see whether we can reduce this nonlinear partial differential equation to any of the standard forms. So let x is equals to r cos theta and y is equal to r sin theta. So before finding what is dou z by dou x and dou z by dou y, that is p and q, so what is x square plus y square here? X square plus y square is r square cos square theta plus r square sin square theta. That is r square into sin square theta plus cos square theta is 1. Therefore x square plus y square is equals to r square. And what is theta from this? So if we divide y by x is equals to r sin theta by r cos theta, that is tan theta. Therefore theta is equals to tan inverse of y by x. Okay. Now let us see what does this p and q become. What is p? As we know, p is dou z by dou x. Now we can write this dou z by dou x as dou z by dou r into dou r by dou x plus dou z by dou theta into dou theta by dou x. This is by chain rule on z, because z is dependent on r and theta and r and theta are dependent on x and y. So now let us substitute the known values here. This is dou z by dou r, we don't know its value. Dou r by dou x. What happens to dou r by dou x? From this we have r square is equal to x square plus y square. If we find dou r by dou x, what do we get here? R is equals to 1 by root over x square plus y square. So dou r by dou x means 1 by 2 root x square plus y square into internal derivative is 2x. That is 2 gets cancelled. X by root over x square plus y square is r. Therefore this is x by r. Dou z by dou r into x by r. Plus dou z by dou theta is not known to us. So we leave it like that. Like that. What is dou theta by dou x? Theta is tan inverse y by x. Now dou theta by dou x means derivative of tan inverse f of x is 1 by 1 plus f of x whole square into f dash of x. Therefore derivative of tan inverse y by x is 1 plus y by 1 plus y by x whole square into partial derivative of y by x with respect to x. That means y is constant. We need to differentiate 1 by x. Derivative of 1 by x is minus 1 by x square. Therefore, its derivative is minus y by x square here. Now, if we simplify this, we get minus y by x square plus y square. Because y is constant, x square is cancelled there. That is equals to minus y is r sin theta by x square plus y square is r square. So, r gets cancelled. So, we have minus sin theta by r. Therefore, this is minus sin theta by r. Here also in place of x we write r cos theta. Therefore, this is just cos theta. If we write x is equals to r cos theta, r gets cancelled and we get cos theta here. So, dou r by dou x is cos theta and dou theta by dou x is minus sin theta by r. Therefore, this is equal to dou z by dou r into cos theta minus dou z by dou theta into sin theta by r. This is P. P, dou z by dou x. Now, similarly, we find what is Q. Okay, so P is equals to, this implies P is dou z by dou r cos theta minus dou z by dou theta into sin theta by r. This is P. Now, in a similar manner, we find what is Q. So, okay, I'll change here itself. Q is dou z by dou y. Dou z by dou y can be written as dou z by dou r into dou r by dou y plus dou z by dou theta into dou theta by dou y. What is dou r by dou y? R is root over x square plus y square. So, dou r by dou y is 1 by 2 root x square plus y square into 2y. So, this is y by r. But y is here r sin theta. R sin theta by r is sin theta. So, we get sin theta here. Similarly, dou theta by dou y is, theta is tan inverse y by x. Derivative of tan inverse y by x is 1 plus 1 by 1 plus y by x whole square into derivative of y by x with respect to y. Derivative of y is 1. 1 by x is constant. So, we get here 1 by x. Now, if we take the LCM, we get x by x square plus y square. No minus here. What is x? X is r cos theta. So, r cos theta by x square plus y square. X square plus y square is r square. Therefore, this gives cos theta by r. So, here in place of minus sin theta, we get cos theta by r. This is sin theta. Therefore, Q is this. Q is equals to this. So, we obtain P and Q, X and Y. Now, we are going to substitute X, Y values, P, Q values from these 4 equations in the given partial differential equations. Let us see what happens then. Now, substituting the values of X, Y, P and Q in the given partial differential equation, we get substituting X, Y, P, Q in given partial differential equation, that is 1. We get, what is x? X is equals to r cos theta. Therefore, x square plus y square, we know x square plus y square is r square into p square plus q square. What is p square? P is dou z by dou r cos theta minus dou z by dou r into sin theta by r. So, p square means a minus b whole square. It gives dou z by dou r whole square into cos square theta minus 2ab, that is 2 into dou z by dou r into dou z by dou theta into cos theta into sin theta by r plus b square, that is dou z by dou theta whole square into sin square theta by r square. This is p square. plus q square. Q square is dou z by dou r whole square into sine square theta plus 2 dou z by dou r into dou z by dou theta into sine theta into cos theta by r plus b square, that is dou z by dou theta whole square into cos square theta by r square. Now this is x square plus y square, that is r square into p square plus q square is equals to 1. Okay. Now let us simplify this. What do we get here? This implies r square into, see these two terms, this one and this one. Dou z by dou r whole square, if we take common, we have sine square theta plus cos square theta is 1. Therefore, dou z by dou r whole square. These two terms were over. Minus 2 dou z by dou r, dou z by dou theta, cos theta, sin theta by r plus 2 times cancels. And here also we have dou z by dou theta by r square common, and we have sin square theta plus cos square theta is 1. So here we have 1 by r square times dou z by dou theta whole square is equals to 1. That is r square into dou z by dou r whole square plus r square gets cancelled here, dou z by dou theta whole square is equal to 1. This is how we have reduced now. Okay. Now we can write this equation as, so I will erase this. So what did we do here? We substituted x is equal to r cos theta, y is equal to r sin theta, and found the values of p and q, and substituted x, y, p, q in the given partial differential equation, and after simplification we obtain a partial differential equation which is r square into dou z by dou r whole square plus dou z by dou theta whole square is equal to 1. Now we deal with this partial differential equation. Now we can write this partial differential equation as r dou z by dou theta whole square plus dou z by dou r whole square plus dou z by dou theta whole square is equals to 1. Now this equation resembles f of x power m into p comma y power n into q is equal to 0. Right? So we have r dou z by dou r, x power m into dou z by dou r, we can call it as some capital P, dou z by dou theta, no y power n here. So what is the substitution we take in this case? We take capital X is equals to x power 1 minus m if m is equals to 1, and log x if m not equals to 1. So here in this case we have m is equals to 1, r power 1. So what is the substitution we must take? Let capital R is equals to log r. You can use any other variable here, not just capital R, you can use any other variable. I take capital R here. Capital R is equals to log r. Then what is dr by dr? Is 1 by r. Now consider dou z by dou r. Dou z by dou r can be written as dou z by dou capital R into d capital R by dr. dr. That is equals to dou z by dou capital R into dr by dr is 1 by r. From this r into dou z by dou r is equals to dou z by dou capital R. Dou z by dou capital R. You can call capital dou z by dou capital R as P. So I write r into dou z by dou r is equals to capital P, where I take capital P as dou z by dou capital R. Now substitute r into dou z by dou r as capital P in this equation. Let us call this equation as 2. Now substituting in 2. In equation 2, what do we get? R into dou z by dou r. What is R into dou z by dou r? It is P. So this is P square plus dou z by dou theta. You can call this as Q square is equals to 1, where P is equals to dou z by dou capital R and Q is equals to dou z by dou theta. So we could take P square plus Q square is equal to 1. Is it a non-linear partial differential equation? Yes, because we have P square and Q square. Is it in any of the standard forms? Yes, it is in standard form 1 because it involves only P and Q. So call this equation as equation number 3. Equation 3 is in standard form 1. So we have reduced the given equation finally to standard form 1. Now here onwards we can solve as in the procedure of standard form 1. So how do we obtain solution for the equations which are in standard form 1? We take the solution to be z is equal to ax plus by plus c, isn't it? So let the solution be ax, but here it is not x. In place of x we have capital R, plus by, in place of y we have theta, plus c, be the solution of equation 3. Okay. Now what is dou z by dou r from this equation? Dou z by dou r is a, isn't it? Dou z by dou r from this equation is a. Similarly, what is dou z by dou theta? Is b. Now substitute dou z by dou r and dou z by dou theta in equation 3. So from equation 3 what do we get? Equation 3, dou z by dou r, that is p, is equals to a. So it is a square plus q, that is dou z by dou theta, q square is b square is equals to 1. What is b from this? B is equals to plus or minus root over 1 minus b square. Okay. Therefore, what is the solution now? Z is equal to AR plus what is B? B is, this is A square. B is less or minus square root of 1 minus A square into theta plus C is the general solution. Now let us resubstitute the values here. What is capital R and capital theta? So that is Z is equals to A into what is capital R? It is log R plus or minus square root of 1 minus A square into theta plus C. That is Z is equals to A into log R. What is log R? Log of R is root over x square plus y square. Square root of x square plus y square plus or minus square root of 1 minus A square into theta is tan inverse of y by x plus C is the general solution of given partial differential equation, that is x square plus y square into p square plus q square is equal to 1. So this is the general solution. So in such cases we can take substitutions like we have taken in this problem, because here we have x square plus y square. I took substitution as x is equals to r cos theta and y is equals to r sin theta. So depending on the terms we can take the substitution. We can choose the substitution. Okay. We see one more problem. Now look at this problem. Solve the partial differential equation x plus y into p plus q whole square minus x minus y into p minus q whole square is equal to 1. So this is also a non-linear partial differential equation and it is not in any of the standard form, nor it is in any of the form which can be reduced to standard form, which we discussed earlier. That is f of x for n into p, y for n into q, or f of z for n into p, z for n into q. It is not of this form. Here also we need a special substitution here. So if we check the equation, we can identify the substitution. So can you guess what is the substitution here? You have x plus y into p plus q whole square minus x minus y into p minus q whole square is equals to 1. So if you observe the equation, you can guess the substitution. What is the substitution we can take here? Yes, we can take x plus y as capital X and x minus y as capital Y. And derive what is p plus q and what is p minus q. And so we substitute all these values in this equation and let us check whether it reduces to standard form 1 or the equations which can be further reduced to standard form 1. So what is substitution we take here? Let capital X is equals to x plus y. Instead of x plus y, we take x plus y. We take it as x square, so that because we have p plus q whole square here, x square may help us instead of x. And we take y square as x minus y. So what is capital X now? Capital X is square root of x plus y and capital Y is equals to square root of x minus y. Now let us find what is P and Q. What is P? P is equals to dou z by dou x. Now this dou z by dou x can be written as dou z by dou capital X with these new variables x and y. Dou z by dou capital X into dou x by dou x plus dou z by dou capital Y into dou capital Y by dou x. That is equals to dou z by dou x is not known to us, so we keep it like that only. Dou capital X by dou x. What is partial derivative of x with respect to x? Derivative of root over x plus y is 1 by 2 root x plus y into derivative of x plus y with respect to x is 1. Derivative of x is 1, derivative of y is 0. Plus dou z by dou y is not known to us, so we just carry it down. What is dou y by dou x? Derivative of square root of x minus y is 1 by 2 root x minus y into internal derivative. Derivative of x minus y with respect to x. Derivative of x is 1 minus derivative of y is 0. So 1. So what do we get here? Dou z by dou x into 1 by 2 root x plus y. But root over x plus y is x. So this is 1 by 2x plus dou z by dou y into 1 by 2 root over x minus y is y. Therefore, P is dou z by dou capital X into 1 by 2x plus dou z by dou capital Y into 1 by 2y. So this is P. Now similarly, we derive Q. So what is P? P is equals to dou z by dou capital X into 1 by 2x minus dou z by dou capital Y into 1 by 2y. This is, plus. This is what we obtained. Now let us find what is Q. Let us change this. Q is dou z by dou y. Now this can be written as dou z by dou x into dou z by dou x by dou y plus dou z by dou y into dou capital Y by dou y. This is by chain rule, which is equals to dou z by dou x into what is dou x by dou y. Dou x by dou y is 1 by 2 root x plus y into internal derivative. Internal derivative of x plus y with respect to y. Derivative of x is 0, derivative of y is 1 because we are partially differentiating with respect to y. So this is 1 here. Dou z by dou capital Y into dou y by dou y. Dou capital Y by dou y is 1 by 2 root x minus y into internal derivative with respect to y. Derivative of x is 0 minus derivative of y is 1. So we get minus 1 here. Therefore, this is dou z by dou capital X into 1 by 2x minus dou z by dou capital Y into 1 by 2y. This is Q. This is Q. Therefore, Q is dou z by dou capital X into 1 by 2x minus dou z by dou capital Y into 1 by 2y. Okay, now we are going to substitute all these values in the given partial differential equation. We know what is x plus y, x minus y, p plus q and p minus q. What is p plus q from this? P plus q, when we add these two terms will get cancelled and we get 1 by x times dou z by dou x. 1 by 2, 1 by 2 gives 1. Similarly, p minus q, when we subtract these two terms, p minus q, then these two terms will get cancelled and we get 1 by y times dou z by dou capital Y. So check these two, p plus q and p minus q gives 1 by x dou z by dou x, and p minus q is 1 by y dou z by dou y. Now we substitute all these in the given partial differential equation. Now substituting in the given partial differential equation all these values, let us see what happens. We have x plus y here. What is x plus y? Capital X square. So this is capital X square. P plus q whole square. P plus q is 1 by x times dou z by dou x. So p plus q whole square is 1 by x square into dou z by dou x whole square. Minus x minus y. X minus y is y square into p minus q whole square. P minus q is 1 by y dou z by dou y. So p minus q whole square means 1 by y dou z by dou capital Y whole square is equals to 1. Now cancelling x square and y square here, we get dou z by dou capital X whole square minus dou z by dou capital Y whole square is equals to 1. Okay. Now if we write dou z by dou capital X as capital P, this is P square, and dou z by dou capital Y as capital Q square is equals to 1, where capital P means dou z by dou capital X and Q is dou z by dou capital Y. Now look at this equation. P square minus Q square is equals to 1. This comes under standard form 1, non-linear partial differential equation, which is in standard form 1 because it involves only P and Q terms. So we write this as equation 2. Now equation 2 is in standard form 1. If it is in standard form 1, how do we solve it? We take the solution to be z is equal to ax plus by plus c. So let z is equals to ax, which x? Capital X and capital Y, because in the derivatives capital X and capital Y are independent variables here. Ax plus by plus c be the solution of equation 2. Now from this, what is capital P? Capital P means dou z by dou x. What is dou z by dou x from this? Partially differentiating with respect to x, we get A. And similarly capital Q. Capital Q means dou z by dou y. Dou z by dou y from this is B. Now put P is equals to A and Q is equal to B in equation 2. Put P is equals to A and Q is equals to B in equation 2. Then what do we get? A square minus B square is equals to 1. From this, find what is B. B is equals to plus or minus root over A square minus 1. So we substitute B here. Therefore, Z is equal to AX plus B. B means plus or minus root over A square minus 1 into Y plus C. Now let us resubstitute what is capital X and capital Y. So Z is equals to A into what is capital X? Square root of X plus Y. Plus or minus root over A square minus 1 into capital Y is square root of X minus Y plus C. This is the general solution for given partial differential equation. Okay. So this is the given partial differential equation. In this we substituted x plus y is capital X square, because here we have squares. We took capital X square and x minus y as capital Y square and derived what is x plus y, x minus y, p plus q and p minus q. We derived p, q, then we find it out p plus q and p minus q, and we all substituted those values in this partial differential equation, which has then reduced to a partial differential equation in standard form 1. Because it is in standard form 1, we assume the solution to be a capital X plus b capital Y plus c, and finding p and q values and substituting in equation 2, we obtain the general solution as ax plus or minus root over a square minus y into y plus c. Now again we are resubstituting what is capital X and capital Y. Capital X is root over x plus y, capital Y is root over x minus y, which gave us the solution, general solution of the given partial differential equation. So in this way, From the given partial differential equation, sometimes we have to identify the suitable substitution which reduces it to any of the standard form. Okay. So keep practicing these sums. Hope you understood these problems which we have discussed. Keep learning. Thank you for watching this video.